Hello, we are doing a lesson today on lines and the coordinate plane. When you're looking at what's called a Cartesian or plane or an XY axis, what you're looking at are a horizontal line and a vertical line. The example that's being shown is the line in red, which is y equals 1/2 x plus 2. The line in blue, which is y equals -3/5x minus 8. These are graphs of lines that are put on top of an XY axis. So let's talk about the XY axis. Let's talk about plots and points and things like that, and then we'll talk about the lines themselves. An XY axis looks like this. The horizontal line in the middle is a number line called the x-axis. The vertical line in the middle is called the y-axis, and it's a number line called the y-axis. These are number lines because even though they're not given there, each space represents a number. It does not stop at 10. It goes from -infinity on the left all the way to +infinity on the right. The y-axis goes from -infinity on the bottom up to +infinity all the way up top. The coordinate plane has two axes. Again, the x-axis is the horizontal line right in the middle here. The y-axis is the vertical line, given by the vertical line in the middle here. Both of these axes go on forever in both directions, again from -infinity up to +infinity. This xy axis has 4 quadrants. I'll number them here. Quadrant 1 on the upper right, quadrant 2 on the upper left, quadrant 3 on the lower left, and quadrant 4 on the lower right. The middle of this graph is called the origin. That's where the x and y axis intersect. Let's look at something called a table of values. A table of values is a representation of a relationship, an algebraic relationship. This one says y equals x. So if we were to fill out this table of values, what this means is that y is the same number as x. That's what it means for them to be equal. On the other side, this relationship shows something slightly different. Y equals 2x. So what this means is that whatever x is equal to, y is going to be equal to 2 times that number. And that's going to equal its own number. In this case, 0 and 2, -2, 4, 2 times 1/2 is 1. The numbers that we are using don't have to be whole numbers. They don't have to be integers. They can be fractions and decimals and radicals and all those types of great values. This table of values represents an ordered pair, an x and a y. Every ordered pair is represented by an x coordinate and a y coordinate. The x is given first and the y is given second. Every ordered pair follows this format. And the numbers don't have to be the same, even though they are over here in all these examples. But once we jump to these numbers here, like 1/2, 1, you can see that the x and y coordinates can be different. They can be positive or negative numbers. Most of the time they will be integers, but they can be fractions in some cases. A graph is a visual, this table, is a kind of a table representation of this relationship. When you graph a line, you're graphing a visual representation of this algebraic relationship. Graphing lines means that you first have to be able to plot points that the lines go through. So let's talk about plotting points with an ordered pair. And again, all real numbers are represented, integers, fractions, irrational numbers, but not complex or imaginary numbers that we studied before. Those are not represented here on this xy axis. So we want to plot these 9 points here. Let's start with A on the upper left. When you plot a point, you are starting from the origin and you are moving the x-coordinate first. You are moving either positive or negative depending on what the number is. Positive means that you're moving to the right and negative means that you're moving to the left. So what that means is from the origin here, you're either moving right or you're moving left, depending on if that number is positive or negative. And from that point, you're following the y-coordinate. You're either moving up if y is a positive number, or you're moving down if y is a negative number. So again, from the origin here, you're going to the right maybe a certain number of spaces, and then you're moving up if both those numbers are positive. You can move to the right and then down if x is positive and y is negative. You can move left and up if x is negative and y is positive. I'll write this down. Oops. Minus plus here. You can also move left and down. That's if both x and y are negative values. And like I said before, if you go to the right and then down, that means x was a positive number and y was a negative number. Excuse me. So let's plot the origin first. Again, that's 0 spaces left or right and 0 spaces up or down. That's why the origin is right in the middle. Let's look at B, which is 2, 5. That's 2 spaces to the right, so 1, 2. That's 5 spaces up, bringing us right in that line over there. So again, we won't draw these lines. We don't want to put those down. All we want to do is put the point in the right location based on that movement that was, I'll say, invisible. Point C, 4, -7, goes 4 spaces to the right. That's going to go right there. And then from there, 7 spaces down, so right over here, which I'll plot again, we don't want to draw these lines going to the right and down because all we care about is the location of the point. We don't want to draw lines that are supposed to be invisible. Let's look at D, -5, 3. All right, so sometimes we could do this, 1, 2, 3, 4, 5 spaces to the left. Again, but we don't want to actually show those dots when we're putting on our finished product. 3 spaces up from there, 1, 2, 3, means that this ordered pair, point D, -5 plus and +3, is up in quadrant number 2. -9, -1. So let's show this with a tail. 9 spaces to the left, 1 space down, puts us right over there. So that's -9 and -1. Over here is -7. Over there is +3. That was point E. Point F, 0 for x, but 6 up. So that's again 0 spaces left or right. That means we're not moving left or right, but we are going 6 spaces up to that point right there for F. Point G, -2, 0, means 2 spaces to the left and 0 spaces up or down. So again, that's from here over to the left twice, and then not moving up or down. How do we graph a fraction or a decimal? Graphing a fraction or a decimal is one of the only rare instances where it is okay to turn a fraction into a decimal. Right? It's difficult to visualize a fraction like -13/2 and figure out where it belongs along this number line. it's much easier to look at it in decimal form. So in your calculator, divide negative 13 divided by 2, you get negative 6.5. Negative 25 divided by 8 is negative 3.125. 1 divided by 2 is 0.5. So let's graph point H first. Point H is 5 units to the right, and then half a unit up. So let's zoom in here. That's going to be from here, 5 units to the right. And if we go up over here, that's 1 full unit. So we only want to go halfway up. And when you're plotting this kind of point, you do not have to be fully exact. Just be in the right, between the right two numbers, essentially. So let's look at this one, negative 6.5. So negative 5 is here, which means negative 6 and negative 7 are here. Negative 6.5 is going to be in between right there. And then negative 3.125 is going to be between negative 3 and negative 4. So if negative 6.5 is here, between negative 3 and negative 4, a little bit closer to negative 3, we see that the intersection is right over there. And again, I'm using a nice iPad here, so I can go ahead and erase these lines. If you're doing this on paper, you won't have that privilege. So point I is roughly in this location. Again, you do not have to be fully exact with these decimals, just in between the right two numbers. So that's how you plot points. And we're going to use that in order to plot a line given as 2x minus 3y equals 12. This is the equation of a line right here. And this equation of a line is given to us in what's called standard form. The best version of a line, the best form, is called slope-intercept form. Slope-intercept form means we want to solve for y. So we're going to subtract 2x from both sides, and since 12 and 2x are not like terms, that means that we don't actually add or subtract them together. We can now isolate y by dividing the number in front of it, negative 3. And everything gets divided by negative 3. That's 1, 2, 3 terms in this equation. That means negative 3 is getting divided 3 times. Y is equal to positive 2 over 3x, because a negative over a negative is a positive. And then minus 4, because 12 divided by negative 3 is equal to negative 4. So here's what we are doing with this slope-intercept form. I'm not a hero, I'm a delivery boy. So y is equal to 2 over 3x minus 4 is our key. So let's pick some values for x. We can pick anything we want to. The best number to pick is 0. Beyond that, I'm going to pick 6. I'm going to pick negative 3. And the reason for that is that I can see that the denominator here is a 3. So we want to pick multiples of 3 for these other two numbers. We could pick positive 3. We could pick 12, 15. And those will work out nicely. But if we pick numbers like 7 or even 2, we're going to end up with fractions, and that's not going to be ideal. We have a choice. So we're going to make our life as easy as possible with these choices. Next up is substitution. Y equals 2 over 3x minus 4 is our equation. So that means we're going to have 2 over 3 times 0 minus 4, because we're plugging in 0 for x. Y equals 2 over 3 times 6 minus 4, plugs in 6 for x. And y equals 2 over 3 times negative 3 minus 4, plugs in negative 3 for x. So this is going to be 0 minus 4, which is equal to negative 4. And this results in an ordered pair of 0, negative 4. We chose an x, and this work here tells us a corresponding y coordinate so that we can build an ordered pair from there. 6 divided by 3 is 2. So this becomes 2 times 2, which is 4 minus 4, and that's going to equal 0. So that's going to be 6 comma 0 as this ordered pair. Negative 3 divided by 3 is negative 1. So negative 2 times negative 1 is equal to negative 2. Minus this 4 gives us negative 2 minus 4, which is negative 6. So the ordered pair is 3 comma negative 6. Oh, that's negative 3 comma negative 6. So let's move down and let's graph these 3 points first. Our first point was located at 0, negative 4. Our second point was located at 6 comma 0. So that's 6 spaces to the right, 0 spaces up or down. And the third point was located at negative 3 and then negative 6. So the intersection of these two lines right over there. So let's put that point right there. And what you should get is something that looks like this, which now we can draw a straight line through. And 3 points is going to give us 3 points is going to give this for us. 2 points is not enough. 3 points is ideal because that means if you make a mistake, you should be able to see that these points are not aligned. Points have to line up in order for this to be correct. Let's label this line y equals 2 over 3x minus 4. And we have now a straight line. Now I know these 3 points here are highlighted, but in reality, all of this line going from the lower left to the upper right is made up of an infinite number of points, an infinite number of ordered pairs. For instance, you can see over here at 3, negative 3, there's an ordered pair that this line is a part of. You can see over here between 7 and 8, maybe 7.5, and then 1, you can see that this line kind of intersects that ordered pair. In order to verify that, we can choose a value of x and c. And you can see if we zoom in, over at 7, this is still an existing ordered pair, even though it's not at an integer value. It's going to be a decimal or a fractional value. So again, a line is equal to an infinite number of points, or rather an infinite number of ordered pairs. Thank you for watching.